Imagine Mars, a world both familiar and utterly alien, a place that has captivated our imaginations for generations. A cold, silent desert under a pink sky, a landscape sculpted by time and the harsh realities of a dying planet. The thin atmosphere offers little protection from the sun's radiation, painted in rust and ochre. A palette of iron oxides dominates the view, a testament to the planet's ancient watery past. For centuries we've wondered, peering through telescopes, sketching faint details on a distant world. Could life exist on this alien world? Could something thrive in this seemingly inhospitable environment? A question that has driven countless missions and fueled our scientific curiosity. In 2011, something caught our eye, a flicker of the unexpected in the vast expanse of Martian data. Dark, mysterious streaks appeared on Martian slopes. Seemingly out of nowhere, these features presented a new enigma. These marks crept down hillsides like ephemeral rivers, carving their way through the rusty terrain. Growing longer in the warm season when temperatures on the surface dared to climb above freezing, then fading in winter, retreating back into the shadows as the Martian landscape froze once more. The cycle repeated, year after year, a rhythmic pulse on the face of the red planet. A tantalizing clue, a whisper of something more. Was this the signature of liquid water, the lifeblood of our own planet, flowing on Mars today? A revolutionary idea that challenged our understanding of the planet. Scientists called them recurring slope lineae, or RSLs, a formal name for a phenomenon that defied easy explanation. The excitement was electric, a surge of hope that we might have found evidence of present-day water activity. Could this be evidence of life's most essential ingredient, a potential habitat for Martian organisms? But science is a journey, not a destination, a constant process of questioning, testing, and refining our understanding. Each answer leads to new questions, deeper mysteries that beckon us to explore further, and every mystery solved opens the door to more, revealing the intricate complexity of the cosmos. So let's follow the clues left by our robotic explorers, the tireless sentinels on the Martian surface, and unravel the truth behind these Martian shadows, these enigmatic RSLs that continue to puzzle and inspire us. This isn't just a story about geology, about rocks and minerals and the forces that shape a planet. It's about our relentless curiosity, our innate desire to understand our place in the universe. The universe is whispering its secrets, offering glimpses of its hidden wonders. Let's listen, and together let's explore the mysteries of Mars. When images of the dark lines reached Earth, headlines blazed. Liquid water on Mars. For decades we knew Mars had water, but only as ice or locked underground. The idea of salty brines briefly flowing on the surface was thrilling. The streaks appeared when temperatures rose above -23 degrees Celsius, just warm enough for briny water to melt. Spectrometers detected hydrated salts in the streaks, hinting at recent moisture. The evidence seemed to point to a dynamic, possibly habitable Mars. Could hardy microbes survive in these fleeting flows? The RSLs became beacons of hope, prime targets for future exploration. We dreamed of sending rovers to these sites, searching for signs of life. But science demands scrutiny. Every observation, every data point must be rigorously examined and verified. It's not enough to simply see what we want to see. We must challenge our assumptions and seek out alternative explanations. As our cameras improved, offering unprecedented resolution and detail, the story changed. What once seemed clear and straightforward became increasingly complex and nuanced. High-rise images showed the streaks only formed on very steep slopes, steeper than a black diamond ski run. These weren't gentle inclines, they were near vertical drops. Flowing water should spread out, carving channels and creating a fan-like pattern as it descends. But these streaks hugged the angle of repose, just like dry sand cascading down a dune. Up close, there were no channels or erosion, no telltale signs of flowing liquid, just a change in color, a subtle darkening of the Martian soil. The wet patches looked more like an optical illusion, a trick of the light and shadow. And the amount of water needed to create these streaks, if they were indeed caused by water, was enormous, far more than Mars could supply, given its current arid state. No evidence of underground aquifers, no reservoirs of water hidden beneath the surface, no sign of water left behind, no dampness, no mineral deposits. The beautiful idea of flowing Martian rivers, a vision that had captivated scientists for decades, was unraveling. The evidence pointed elsewhere, suggesting a different mechanism at play. Science isn't about clinging to hope, it's about following the facts, wherever they may lead, even if it means abandoning cherished theories. The Martian riddle was deeper than we thought, a more complex puzzle than we had initially imagined. The search for answers continued, driven by curiosity and the unwavering pursuit of truth. With the water theory fading, scientists looked for a new explanation. The answer: avalanches of dust and sand, triggered by gravity on steep Martian slopes. A thin layer of bright dust covers darker sand beneath. A small trigger sets off a granular flow, revealing dark streaks. This model explains the steep slopes, the seasonal growth, and the fading in winter as new dust settles. No water required, just wind, dust, and gravity. Even the hydrated salts can form by pulling vapor from the air, not from liquid water. The Martian water mystery was solved, not by rivers, but by dust slides. Sometimes the simplest answer is the right one. So, the streaks aren't water, as we initially hoped. The evidence points to a different explanation, a fascinating one nonetheless. These dark features, once thought to be signs of flowing water, are now understood to be something else entirely. But Mars is no less fascinating. Its beauty lies not just in what we find, but in the questions it provokes. The red planet continues to captivate us with its mysteries and challenges. This is science in action, a testament to human curiosity and our relentless pursuit of knowledge. We observe, hypothesize, and test, pushing the boundaries of our understanding. A thrilling idea, tested and refined by evidence. Each new piece of data brings us closer to the truth, even if it means overturning our previous assumptions. By solving this mystery from orbit, using sophisticated instruments and techniques, we gain a deeper appreciation for the complexity of Mars. We can focus our search for life on more promising sites, areas where the conditions might be more conducive to microbial existence. This is about refining our search strategy. Ancient river deltas, remnants of a wetter past, hold clues to the planet's history and potential for past life. Buried ice, a valuable resource and a potential habitat, offers another avenue for exploration and discovery. Mars is still geologically active, a dynamic world shaped by forces both ancient and modern. Shaped by wind and dust, these forces sculpt the landscape, creating ever-changing patterns across the surface. Not water, but something equally compelling. The absence of abundant surface water doesn't diminish the planet's allure. The surface changes season by season, revealing subtle shifts in color and texture as the planet responds to the sun's influence, revealing a dynamic world, constantly evolving and surprising us with its hidden secrets. Understanding these dry processes, the forces that shape the Martian landscape in the absence of abundant water, is crucial to unlocking its history. It teaches us to read the language, the subtle clues etched into the rocks and soil, that tell the story of a planet's evolution. Of a desert planet, a world that challenges our assumptions and expands our understanding of planetary science. The journey from water to dust, from a potentially habitable world to the arid landscape we see today, is a story worth unraveling. Mirrors the history of exploration itself, a journey of discovery filled with unexpected twists and turns. We wonder about the possibilities that lie hidden beneath the surface, about the secrets Mars still holds. We test our instruments and our theories, pushing the limits of what we know and striving to learn more. We learn, with each new discovery, with each new insight, we deepen our understanding of this fascinating world. Each discovery sharpens our view, bringing the Martian landscape into ever greater focus, and deepens our understanding of the processes that have shaped Mars over billions of years. The thrill isn't just in finding what we expect, but in uncovering the unexpected, the anomalies that challenge our assumptions. But in the surprises along the way, the unexpected geological formations, the puzzling chemical signatures, the mysteries that beckon us to explore further, Mars keeps us curious, driving us to ask new questions and seek new answers. The cosmos is always more wonderful than we imagine, and Mars is a testament to that wonder, a world that continues to inspire and challenge us. The quest for life on Mars is far from over. Mars was once warm and wet, with rivers and lakes, prime habitats for life. Our rovers now search ancient rocks for biosignatures, clues to past life. The question is no longer just, is there life now? But was there ever life? The Martian subsurface may still hide liquid water, shielded from harsh surface conditions. Future missions may drill deep, searching for hidden oases. If life ever existed, it may have retreated underground. The dream of finding life on Mars remains real. Our strategy has simply shifted. Each mission peels back another layer of Martian history. The story of Mars is still being written, one discovery at a time. The Martian streaks remind us, our solar system is full of surprises. Each mystery solved reveals new questions. Exploration is a human drive. Our robotic explorers are our eyes across the void. Every image is a postcard from the unknown, inviting us to dream. Studying Mars gives us perspective on our own world's fragility. The universe isn't required to make sense, but it's our greatest adventure to try. The truth behind the streaks was unexpected, but just as exciting. The journey is just beginning. Let's keep exploring.